So again, just the log rules. Basically, I wrote the first three, and then the last one here is log, not the last one, as a matter of fact. I'm going to write a few more. Log x over y, which is x divided by y. I could change that to log x minus log y. Also, if I have a to the power of log base ax, that would be x. So the a and the log base a cancel each other out. Also, we have what we call change of base. So basically, we're changing to base 10 most of the time, but we could change to any base we like. So if we have log base a x, that would equal log x over log a. Here, the base was a, but we could change this to log x over log a, and then the base becomes 10. Okay. So if I have, let's say, log base 2, 8, this is easy because it's basically this raised to this power gives me this. So 2 raised to what power gives me 8, then you know that has to equal 3. That's easy because you know 2 to the power of 3 will give me 8. So log base 2, 8 gives you 3. But if I write log base 2, 7, and you want to solve that, 2 raised to what power gives me 7, you don't know, because that's not as obvious. And it's going to be a decimal answer. Then you could change it to log 7 over log 2, and you put it in your calculator, and that will give you the exact or the decimal answer to this, and you could just round it to 1 decimal or 2 decimals. Okay. And then I'm going to write a few extra rules here that will help you with some of the tough questions. If I have log and the base is a fraction, so 1 over ax, just know that you could change that to negative log base ax. I could prove that to you later if you want me to, but for now, just remember, if the base is a fraction, you could change it to a whole number, and then you put a negative right here, and that's allowed. And I could show you later on. I could show you later on how that is. And then also, if you have log base a to the power of m here of x, so the base has an exponent that could be changed to 1 over m log base ax. And the reason I'm showing you this, because sometimes you have a log base 2 in a question, and then a log base 4 or base 8, for instance, x, and they want you to combine them. You cannot combine them unless you change this to the same base as this. And therefore, the log base 8 becomes log base 2 to the 3, because that's what 8 is. And then you could take the 3 and make it 1/3 right in front of here. And now both of them, they have the same base, and you're able to combine them. After you, of course, you raise the 1/3 right there and all of that. Does that make sense? So these are the rules that I want you to know, and I want you to write them down if you haven't written them down, because as we're exploring logarithmic questions, you need to know these. So please, if you haven't written them down, write them down and let me know once you finished, because then I'm going to go to logarithmic and exponential questions that we're going to do in this chapter. Okay. So now here are some questions. So we're just gonna do a few questions from here. Now, the first one, log base 5, 25 equals y, and they want you to find y. We know when it's logs, it's this raised to this gives me this. And therefore, 5 raised to the power of 2 will give me 25, so y equals 2. Log base 1/7 7 equals y. So here, this what this means. It means 1/7 to the power of y equals 7. Now the 1/7, we could change that to 7 to the power of -1 y equals 7, or 7 to the power of -y equals 7 to the 1. Cancel the bases. Negative y equals 1, and therefore y would equal -1 here. Or basically 1/7 to the power of -1 will give me 7. Does that make sense? Yeah. Now I'm just going to give you a few questions here. I want you to do number 3, number 4, number 11, number 10, number 5, and number 9. So just do these for me, send me your answers, and then we'll go from there. So this here will be 16 to the power of y equals 4. And then this exponential form, the best way to solve it, change both bases to base 2, because 16 could be changed to 2 to the power of 4y. And this 4 could be changed to 2 to the power of 2. Once the bases are the same, you could cancel them. And then you have 4y equals 2, divide both sides by 4, you'll end up with y equaling 1/2. Okay, and I think all of you sent me that answer. Here, the same thing with number 4. You want to go 2 to the power of y equals 1/8. 2 to the y equals 1/2 to the power of 3. So I'm making the bases the same, but this two bases are not the same yet because that's 1/. So what you do, you go y, you go 2 to the y equals, bring that up and make the exponent negative. Now the 2's cancel, y equals -3. 5 to the power of y equals 1, and 5 to the power of 0 would give you 1, so y would equal 0. 9, it's y to the 5, because the base here is y, so y raised to the power of 5 equals 32, and we know 2 to the power of 5 will give me 32, so y equals 2. Here, 10, 9 to the power of -1/2 gives me y. And y would equal 1/9 to the power of 1/2. And 9 to the 1/2 is the same as the square root of 9. So this would be 1/3. I think Mariani forgot to take care of the negative sign right there. And the last one is, I'm going to write that right here. 4 to the power of y equals 1/8. I think your best bet here to change everything to exponential to the same base as far as the exponent is concerned. So this is 2 to the power of 2y equals 1/2 to the power of 3, which will give me 2 to the power of 2y equals 2 to the power of -3. Cancel the bases. 2y equals -3. Y equals -3/2. And that's how you do this ones right here. So the first one here, as I said, you could make this. That's what they ask you. Log base 3, 1 equals what? 3 raised to this will give you 1, and that's how I found 0. Now you'll be able to do this, this, and this. You might struggle with this. So try to do from 2 all the way to 6. But I expect you to be able to do 2 to 5. Okay, you can make this equal x and then change it to exponential form and go from there. So just do 2 to 5 and then try 6. If you're stuck on 6, just let me know so I could go straight ahead and do that for you guys. Go ahead. So again, this here log base 4, that's just 1. 4 to the power of what gives you 4? That's 1. Here you just bring the 3 down and you have log base 7, and log base 7 is 1, because when the base and what you're logging is the same, it's 7 to the power of what equals 7. That's 1. 3 times 1 is 3. So that's 3. Here, remember, we said when I gave you the rule b to the log base b, they cancel out, and this will also be 3. This here, you go 25 to the power of x should equal 5 to the power of 3. You want to make the bases the same here. So 25 is 5 squared, and you still have the x equals 5 to the power of 3. Cancel the bases. 2x equals 3. X equals 3/2. 16 to the power of log base 4, 8. So this, I want to make it same as this question here. So 16, I could change that to 4 squared log base 4, 8. And then I change that to 4 log base 4, 8 squared, which gives me 4 to the power of log base 4, 64. And then the log base 4 and the 4 here cancels, and the answer is 64. So write the following expressions in terms of log of x, y, and z, or logs x, y, and z. Log x squared y, we could change that to log x squared plus log y, because these two things are multiplied. Then I could do that, and then this will become 2 log x plus log y. So they want you to write it like this. They don't want you to leave the 2 on top. The 2, you bring it down using the power rule for logs. Yeah. If I'm given number 3 log, and you know what? I'm going to start changing this to exponential form. So that's x to the power of 1/2. Then y to the power of 2/3, because that's how you change from exponential, from radical form to exponential form, over z to the power of 4. And now this becomes log x to the half plus log y to the 2/3 minus log base, the base is 10 here, so z to the power of 4. So I just expanded this, and this on the bottom means it's minusing. Now this will give you half log x plus 2/3 log y minus 4 log z, and that's how far they want you to go. Okay, So now what I want you to do here, I want you to do this, number 4, number 5, number 6, number 7, number 9, and number 10. That's it. I don't want to do more than that. So please do them and send me your answers. So if I have log x over y, z, so anything that you divide by, it takes a negative sign. Even though they are besides one another like this, what you should have written, you should have wrote log x, because that's on top, and anything on the bottom takes a negative. Even if you want to go through the details, you could say, okay, this is log x minus, and because y is z on the bottom, then you open brackets, you go, they're multiplied, the y and the z, so they're going to be log y, log z like this, but you're still minusing the whole thing because of the division sign right here. But the best way to remember it, it's just kind of anything on the bottom takes a negative. And you get log x minus log y minus log z. 6, make sure you distribute the square in here and here. So you got, this becomes log x squared over y squared. Also, you could bring the 2 in the front here, be 2 log x over y, and then that would become 2 brackets log x minus log y, and then you distribute the 2. Later, you could do this, which I'm doing right here. So that's log x squared minus log y squared. Bring the 2 to the front. Here, the same thing, the 1/3 belongs to here and to here, so you could distribute it here and here, or you could just bring the 1/3 down. So I'll do this differently then. I'll just bring the 1/3 down, and then I have log xy, which equals 1/3, and then I'm gonna put brackets here, and I'm gonna go log x plus log y, which will give me 1/3 log x plus 1/3 log y. Number 9, you change everything to exponential form. So that's x to the 1/3. Also, y is going to be to the 1/3. And z is going to be to the 1/3, because all of them have 1, 1 on here, and then the 3 is the radicand. So it's y to the 1/3, z to the 1/3, which equals log x to the 1/3 minus log y to the 1/3 minus log z to the 1/3, which gives me, you bring the 1/3 down, so 1/3 log x minus 1/3 log y minus 1/3 log z. If you don't follow it, something, just make sure you ask me. Okay. Gonna change all of these to exponential form. So that's gonna be log x to the 3/4 y to the 2/4 and z to the 4/4, which becomes log x to the 3/4 y to the 1/2 over z to the 1. And therefore this becomes log x to the 3/4 plus log y to the half minus log z 3/4 log x plus 1/2 log y minus log z, and that's your final answer for that. Does that make sense? This is ln x equals -3. Ln is just another form of log. We call it the natural log. Ln has a base of e. So that's log base e, x equals -3. So if you're solving for x, x is just going to equal e to the power of -3, or 1 over e to the power of 3. Yeah. I'm going to solve few here, and I'm going to get you to do the rest of them, okay? So here again, change it to exponential form and solve it. So I'm going to leave that. But if I'm doing number 3 here, the first thing I'm going to raise the power to the x there. So log x squared. And I'm going to combine these two logs right here. And since they're added, then I could just multiply the 2 and the 3x minus 4. Yeah. Now, once you have only one log on the left-hand side and only one log on the right-hand side, nothing before the log. So if I kept the 2 here, I cannot do what I'm going to do for you. And I'm going to show you. But since I put the 2 on top, now I could cancel the logs. And this gives me x squared equals 6x minus 8. X squared minus 6x plus 8 equals 0. X minus 2, x minus 4 equals 0. So x equals 2 and 4. Now you have to go back and test both of these here. So if I put 2 here, that works. If I put 2 here, that works. That means if you get a negative number, then you cannot do it. Let's say I put 1 here for the x. 3 times 1 is 3. 3 minus 4 is -1. We cannot log a negative number. Then you have to reject that answer. But the 2 and 4 here, both of them, they work. Okay, so both of them are answers, for possible answers for this question, or the right answers for this question. Okay, now I'm gonna do another one, which is number 7. Number 7, I could combine these logs right away because nothing before them right here, and it's addition. So I'm gonna go log x minus 3 equals 1. Now I need to change this to exponential form. The base here is 10, so I'm gonna go x times x minus 3 equals 10 to the power of 1, or just 10. That's x squared minus 3x minus 10 equals 0. I factor these. X minus 5, x plus 2 equals 0. So therefore x equals 5 and -2. Now the -2, if you go back and put it here, you're getting a negative number. So you cannot log a negative number. So -2 has to be rejected. The 5 works on both of them. So that's the answer. X equals 5. Now, based on that, I would like you to do these questions right here. So again, number 4, everything you get the right answer, but for number 4, your answers, both of you differed a little bit. So I'm gonna do number 4 as the final answer that we're gonna do today. So you combine, for number 4, you combine the 2 logs on the left-hand side. So that's log x minus 1 equals log 4x. Now, I could cancel the logs at this stage. Now, x squared minus x equals 4x. X squared minus 5x equals 0. X minus 5 equals 0, and therefore x equals 0 and 5. Does 5 work? 5 works for both of them. Does 0 work? We got log 0 here. We cannot log a 0 either. Not only negative numbers, we cannot log a 0, and we have to reject the 0, Marianne. Sorry, I didn't say that. But see, if you have log 0, okay, you know the base is 10. 10 to the power of what gives you 0? Is there anything when you raise it to a power gives you 0? No, that's impossible. So that's why we cannot log a 0, and 0 is not a possible answer.